Good day and welcome to One-on-One Maths Private Tutors. Today we are looking at O-Level and IGCSE Chemistry for pure chemistry and combined science. The topic is making and identifying salts. Making salts by precipitation. Soluble salts include salts of group 1 elements and ammonium salts. All nitrates and most chlorides, bromides, iodides, and sulfates. So if we have group 1 salts, of which common ones are sodium chloride, potassium nitrate, and lithium sulfate. These are common salts of group 1 elements. These are soluble. All nitrates. So if we have copper nitrate, sodium nitrate, all nitrate salts are soluble. Ammonium salts such as ammonium chloride, ammonium sulfate are all soluble. And most chlorides, bromides, iodides. So these are halide salts, and most sulfates are soluble. Insoluble salts include halides of silver, lead, and sulfates of calcium, barium, and lead. So calcium sulfate, lead sulfate, and barium sulfate are insoluble, as well as halides of silver. So silver chloride, silver iodide, silver bromide. All these are insoluble. Sulfates of calcium, lead, and barium. Halides of silver. Group 1 hydroxides and carbonates are soluble. Most other hydroxides and carbonates are insoluble. So, lithium hydroxide, sodium hydroxide, potassium hydroxide, lithium carbonate, sodium carbonate, potassium carbonate are soluble. Most other hydroxides and carbonates are insoluble. Let's look at this question. Explain using solubility rules if the salts formed by these reactions are soluble or insoluble in water. Aqueous sodium hydroxide and dilute sulfuric acid to give sodium sulfate and water. Soluble salts include salts of group 1. So any salt of group 1 is soluble. So this will be soluble. Aqueous silver nitrate is added to dilute hydrochloric acid. So silver nitrate added to dilute hydrochloric acid will give us silver chloride and nitric acid. So insoluble salt includes halides of silver. So this will be the silver chloride will be a precipitate, which is a solid. So the salt will be insoluble because a precipitate of silver chloride will form. Halide salts are salts containing the ions of fluorine, chlorine, bromine, or iodine. And in questions about salt preparation, you may be given information about the solubility of the reactants and products. This can be an equation with state symbols. So we should be able to use the state symbols to determine the state of the reactants as well as the products. Salts of group 1 elements and ammonium salts. All nitrates and most chlorides, bromides, iodides, and sulfates are soluble in water. Halides of silver and lead, sulfates of calcium, barium, and lead, and hydroxides, except those of group 1, are insoluble in water. Let's look at this question. Describe how to prepare a pure dry sample of silver iodide from aqueous silver nitrate and a named soluble salt. First, we must name our soluble salt. Any group 1 salts are soluble. So we can choose potassium iodide as our soluble salt. And we have silver nitrate. So when we react potassium iodide and silver nitrate, of which we have been told silver nitrate is aqueous, so it is soluble in water. Potassium iodide is also soluble in water. This will give us potassium nitrate and silver iodide, which is a precipitate, which is solid. So let's look at this experiment. The solution on the left is potassium iodide. So this is potassium iodide. And the solution on the right is silver nitrate. We'll take aqueous silver nitrate and mix it with aqueous potassium iodide. So when we mix it like that, we'll see a precipitate starting to form. So this precipitate is as a result of silver coming in contact with iodide ions and forming an insoluble solid, which we call a precipitate. Then, since the precipitate is a solid, we will use a filter paper. So what we have now is potassium nitrate in solution. So we'll say it's aqueous, and silver iodide as a solid precipitate. So what we'll do is we will take a funnel, a filter paper, and then pour this mixture of potassium nitrate and silver iodide and filter it. So what will remain as the filtrate is the silver iodide, while the potassium nitrate drains off. We'll also pour distilled water to wash the silver nitrate and make sure all the potassium nitrate goes in there, and what only remains on the filter paper is silver iodide. So in the end, we'll have potassium nitrate here in solution and silver iodide. Then we will place this silver iodide in a warm oven to evaporate the water and dry it. So now what we'll do is, one, use potassium iodide salt because it is soluble. All group 1 salts are soluble. So this is our named soluble salt, which contains iodide ions. We want to make silver iodide. Now we mix potassium iodide solution with silver nitrate. This produces potassium nitrate solution and a precipitate of silver iodide. Next, we filter the mixture. Silver iodide is the filtrate. Then we wash the silver iodide with distilled water to remove the remaining potassium and nitrate ions. Then we dry the filtrate silver iodide in a low heat oven. So we remain with pure dry silver iodide. That is the procedure we will take. Convert this simple equation into an ionic equation by showing the ions present in the aqueous reactants and products, cancelling the spectator ions and writing the ionic equation. So from this equation, we have potassium ion, which is a positive ion, plus an iodide ion, which is a negative ion, plus a silver ion, which is a positive ion, plus a nitrate ion, which is a negative ion. So these are all aqueous or in solution. Then this will give potassium ion in solution, plus a nitrate ion in solution, plus a precipitate of silver iodide solid. So now we cancel the spectator ions. Potassium and nitrate ions are just spectator ions. So we have our iodide ion plus our silver ion to give us the silver iodide precipitate, which is a solid. So these are the ions that take part in the reaction. And this is the ionic equation. So now we go to test for ammonia, carbon dioxide, chlorine, hydrogen, oxygen, and sulfur dioxide. Ammonia turns damp litmus paper blue. Ammonia is NH3, and when it gets in contact with water, will give us ammonium hydroxide, which is alkaline because it has a hydroxide there. So an alkaline solution turns red litmus paper blue. Carbon dioxide turns lime water milky. So carbon dioxide plus lime water, which is calcium hydroxide, will produce calcium carbonate, which is a precipitate. So this one is a gas. When it mixes with a solution of calcium hydroxide, it will give calcium carbonate, which is a precipitate, which is a solid. So this solid has a milky color. So carbon dioxide turns lime water milky. Chlorine bleaches damp litmus paper. So whatever color of litmus paper, whether it's red or blue, will all turn white when it gets in contact with chlorine. Hydrogen gives a squeaky pop with a lighted splint. Oxygen relights a glowing splint. Sulfur dioxide turns acidified potassium manganate 7 colorless. So let's look at these experiments to test for gases. So in this illustration, we're going to test for hydrogen, ammonia, oxygen, carbon dioxide, and chlorine. We test for gases in the laboratory because it is nearly impossible to determine the identity of a gas by its appearance. For example, hydrogen, oxygen, and carbon dioxide are all colorless and odorless gases, which means they do not have a smell. To test for hydrogen, place a lit splint. A lit splint is just a piece of wood that is burning with a flame. So when we bring it close to hydrogen, it gives a squeaky pop, which confirms the presence of hydrogen. This is due to the combustion or burning reaction of hydrogen in the presence of oxygen. Because hydrogen is a fuel, it will burn with a sound. This reaction forms water because hydrogen burns in the presence of oxygen to form H2O, which is water. So water is the only product of burning hydrogen. To test for oxygen, we place a glowing splint at the mouth of the reaction vessel or at the mouth of the test tube. A glowing splint is a piece of wood that is burning without a flame. When we place it near oxygen, the glowing splint will relight and form a flame. Hydrogen is highly flammable, and the pop sound that we hear is actually a small explosion. The glowing splint relights in the presence of oxygen, as there is a higher concentration of oxygen in the test tube compared with air, which is only 21%. To test for carbon dioxide will extinguish a burning splint, but the same occurs with ammonia. So the best test for carbon dioxide would be to bubble the carbon dioxide through lime water, which is an aqueous solution of calcium hydroxide. Lime water turns milky in the presence of carbon dioxide due to the formation of calcium carbonate precipitate. Ammonia extinguishes a lighted splint and turns damp red litmus paper blue. So the best test for ammonia is to use a damp red litmus paper. So it will turn blue. Chlorine turns damp blue litmus paper red and eventually bleaches it to white. So it first turns red, then it becomes white. If it is a red litmus paper, it will turn white. Now we go to the test of sulfur dioxide gas. So we use acidified potassium manganate 7 So this is potassium manganate 7, which has a purple color. So if a reaction produces sulfur dioxide gas, you will bubble it into acidified potassium manganate 7, and we expect the color change to be from purple to colorless or clear. So we'll see this change. Now a clear solution. That signifies the presence of sulfur dioxide. Let's look at how gases can be collected. If gases are less dense than air, such as hydrogen or ammonia, they are collected with the tube or gas jar upside down, like this. That's how you collect light gases, because they'll float above air and collect in them. You cannot collect a gas over water if the gas is very soluble in water. And if gases are more dense than air, we use this method to collect the gases, because they will sink at the bottom of air. Let's look at this question. 3 different methods of collecting gases are shown. The relative molecular mass of some gases are ammonia 15, chlorine 71, nitrogen 28, oxygen 32. Suggest which method is best used for collecting A, chlorine, and B, ammonia. In each case, explain your answer by referring to each method. So A, chlorine, we use method B because chlorine is denser than oxygen and nitrogen, which are the main constituents of air. So chlorine has a relative atomic mass of 71, which is greater than nitrogen and oxygen. So it will sink to the bottom, so it can be collected easily. If we use this method, chlorine would go down and out of the collecting tube. B, ammonia is best collected by method A because ammonia is less dense than nitrogen and oxygen. So relative molecular mass of ammonia is 15, nitrogen is 28, oxygen is 32. So the relative molecular mass of ammonia is less, so it will float above air. So the best way to collect is this upside down collecting tube. Suggest why method C is not suitable for collecting sulfur dioxide. So this is collecting over water. Sulfur dioxide is highly soluble in water. So from this tip, we cannot collect a gas over water if the gas is very soluble in water. Give a test for sulfur dioxide and the color change expected if sulfur dioxide is present. Pass sulfur dioxide over acidified potassium manganate B11 or 7. The color change is purple to colorless. Thank you.